Convolution property of DTFT. First, we will see the statement of this property. If x of n has DTFT pair, that is x of omega, and y of n as DTFT pair, that is y of omega, then the statement of convolution of DTFT, that is, if I am representing one signal, that is z of n, it is the what? It is the convolution between x of n with y of n. It is in time domain. Nothing but convolution of two sequences, say x of n and y of n in time domain. For that result, if I am finding the DTFT, discrete time Fourier transform, for that, what will be the result? So we know that the z of n is a time domain sequence. If we calculate DTFT for this, we are getting z of omega. Similarly, convolution operation is there. Z of n indicates it is the convolution between x of n and y of n. For that, for this, if we are calculating DTFT, then what we are getting, that is x of omega into y of omega. It is what? It is the statement of convolution property. Let's prove this statement. Very simple. The meaning of this statement is that convolution of two sequences, nothing but convolution of two sequences in time domain is equivalent to multiplication of their spectrums. X of omega is a spectrum of what? X of n, and y of omega is a what? It is a spectrum of y of n. So we can say that convolution of two time domain sequences is equivalent to multiplication of their spectrums. Let's go for prove this property. Now, with the help of definition of DTFT, I am writing the definition of DTFT. I am writing for z of n. I am applying the DTFT for this z of n. Then what we are getting, z of omega is equal to summation n equal to minus infinity to plus infinity z of n multiplied by e to the power minus j omega n. So with the help of definition of DFT, we calculated z of omega. Very simple, where z of n stands for, it is the convolution between two sequences x of n and y of n. First, let us make use of the definition of convolution. That is, z of n equal to, it is the convolution between x of n with y of n. Okay. Let us make use of definition of convolution. That is summation k equal to minus infinity to plus infinity x of k into y of n minus k. In the previous videos, in the previous sessions, we discussed this definition of convolution sum. Nothing but it is the definition of what? So the given system is said to be continuous time system. For that system, we are finding the response, or we can say output of the system. Then that operation is called as convolution integral. Next, if the system is said to be discrete time system, for that system, if we are finding the response, or we can say output of the system, that operation is called as convolution sum. So here z of n is what? It is a discrete time sequence. So this operation is called as convolution sum. Fine. I am going to substitute this one in the above DTFT equation. See, that is z of omega is equal to summation n equal to minus infinity to plus infinity as it is. Okay, fine. Then what is z of n? Z of n is this much. So I'm going to write in square bracket summation k equal to minus infinity to plus infinity x of k into y of n minus k. Okay. So this one we got what? We replaced z of n. We replaced z of n by this equation. So the remaining part is what? E to the power minus j omega n. Fine. Next step is rearranging the, nothing but changing the order of summations. Change the order of summations. So then I am writing here, that is z of omega is equal to summation k equal to minus infinity to plus infinity. I will take it outside. That is with respect to what? X of k is there. Then the remaining part is what? Summation n equal to minus infinity to plus infinity y of n minus k, okay, e to the power minus j omega n. So because here index k is there, because of that reason I have taken the separate this summation term, but in this case index n is there. In both the terms parameters n is present, because of that reason I taken separately this index k and index n with respect to summation. Now I am going to substitute, put n minus k is equal to m. Here n minus k equal to m, then our equation becomes z of omega is equal to what happens, summation k equal to minus infinity to plus infinity. Okay, then x of k as it is, then summation m equal to minus infinity to plus infinity. This becomes what, y of m, because I substituted n minus k equal to m, hence it is index is m and this term is m, e to the power minus j omega. Here n minus k equal to m we taken, then what happens if n equal to what, m plus k, n equal to m plus k. Here I will write m plus k, in place of n I am writing m plus k. Next simplification, separate the this exponential terms, that is z of omega is equal to summation k equal to minus infinity to plus infinity x of k. Okay, then summation m equal to minus infinity to plus infinity y of m e to the power minus j omega m. Fine. Next e to the power minus j omega k. Okay, one more step I will make use, that is I will separate the terms in such a way that z of omega is equal to summation k equal to minus infinity to plus infinity x of k into this term I will take e to the power minus j omega k. Next summation m equal to minus infinity to plus infinity y of m into e to the power minus j omega m. So let us compare this part with the definition of DTFT. We can write z of omega is equal to, if you compare this part with the definition of DTFT, we can write this is what x of omega. Okay, similarly this part compared with the definition of DTFT, we can write this is what y of omega. Hence we proved convolution. Nothing but convolution of DTFT property is that convolution of two time domain sequences is equivalent to multiplication of their spectrums.